We're going to do halogenation of alkenes via radical mechanisms. Radical mechanisms are pretty, we don't really like using them so much because you pretty much open a can of worms. You get all kinds of molecules, as you're going to see right now. So you will divide it in 3 steps: initiation, propagation, and this will be your termination. So let's focus on initiation right now. The mechanism starts with peroxide, ROOR, and then this will cleave this bond right here between the oxygen and the oxygen. It will cleave, and notice that I am not making the arrows, the curved arrows, I'm not making them full, I'm making them half. That means that in this bond there are 2 electrons. That means that 1 electron is going to this oxygen and 1 electron is going to this oxygen. Half an arrow means only 1 electron migrating. So if you do that, you're going to expect the RO and the electron we show it here, and you expect 2 of those, 1 from this side and 1 from this side. So the next step is going to be this RO is going to come together with an HCl, and the HCl, the bond right here, is also going to cleave. Half is going to come and is going to bond with this radical right here, and you will make this molecule right here. You just form this bond, and then this, the electron in this bond is going to come and is going to form a radical, Cl. Then we move to propagation. Pretty much out of all initiation, what we're looking for is to make this species. So once that we made it, we come to propagation. Propagation, you finally grab your alkene. This is the first time you see the alkene that they give you. And I will say R prime, which anything can come from there, and you have your functional group right here, your alkene double bond. So the alkene is going to cleave and it's going to come together with the radical, and you will make this bond right here, the Cl bond. The 1 electron from here, 1 electron from the double bond, they come together. So the other electron is going to come to the CH. So you have to show it here. You have to show it right here. Then you grab this molecule and you react it with another HCl. This time it's complete. It's like when you grabbed it here. So you have HCl, and you do another homolytic cleavage, which the 1 electron goes to the Cl, and the other electron comes together right here with the radical from the CH. You get it right there. I like putting together the 2 arrows on the plus, if you notice that. You can do it anywhere you want, but it helps me remember that we're talking about radicals over here. So then once you do this, you will get this molecule, you will have another hydrogen right here, and you will have a Cl radical, which I didn't write here, so I will write it for you, Cl radical. Then we go to the termination. Pretty much the termination steps are going to be any 2 radicals that you have seen in the previous steps are going to collide together, and they're just going to bond. Pretty much on this side, you do not want to see any dots. You do not want to see any radicals. So these are just 3 that I gave, but you have more. So you have Cl radical plus Cl radical. Again, I bring them to the plus. So if you make that bond, you will have Cl2, which this will be Cl bond Cl, right? Then another one that I grabbed was our radical alkane, and you put it together with one of the Cl's, and you will have 2 substitutions right there on the same alkene. And then I grabbed the radical that we formed in the propagation, and I put it with another radical with the same species, and you know that this radical will come together with this radical. So you have this one right here, the two CHs making a bond, and then I have the CH2 belonging to both groups, this one and this one. I have them on the same side for you, and I have the R primes on the same side. One important note to remember here is that this will give you an anti-Markovnikov addition of the halogens, and it's simply because the stability of radicals, it's the same order as carbocations. The most stable is going to be tertiary, and the second is going to be secondary, and so on and so forth. So there it is. Okay, so an example of this, we have our alkene right here, functional group. We have HBr, and we have our peroxide. We know that this will be an anti-Markovnikov addition, so we'll have the Br on the carbon that doesn't have the tertiary position, the one with the most amount of hydrogens. So the way we're going to do this is initiation. We have R, O, O, R, and then we know that this will cleave, this one to this side, the other electron to the other side, and then we will get two R, O radicals. First step. Then second step, we grab one of those molecules, R, O radical, and we add the HBr. I'm going to show the bond right here. So the bond is going to do a homolytic cleavage. We know that one electron is going to go to the Br, one electron I will put it to the plus, and this radical electron is going to come to the plus. They will make a bond, and you will get the RO made a bond with the H right here, and plus Br radical. Remember, this is the species that we're looking for. So now that we have it, we will start propagation. So propagation will be our alkene. We'll copy the alkene right here. And it has a methyl group right there, plus the Br radical. So what will happen is one of the electrons from this double bond is going to come and is going to make a bond with this radical right there, and the other one is going to go to one of the carbons in the double bond, either this one or this one. So here's where we have to think of the stability of radicals. So the stability of radicals tells us that tertiary is more stable than secondary, which is more stable than primary, which is more stable than methyl. So if tertiary is going to be more stable, that means that this cleavage is going to go to the tertiary one. So what we're going to find is our structure, and we did not break any sigma bonds. So we have a radical right here on the tertiary, and our Br was added to the other carbon then, right here, with this bond forming right there. And then the next step is going to be grabbing this molecule with my radical right here, plus an HBr, and then this is going to undergo homolytic cleavage. You will have a radical right there. Then the H is going to bring its electron. I'm going to bring it to the plus, and then this radical right here is going to bring its electron. I'm going to do it to the plus too, and then right there you just made a bond between the H and your radical. So you will have this structure completed. You have this one, and you have your BR right here. So that's pretty much what you wanted to make, but you will have a bunch of radicals floating around. So I'm going to do a termination right here. The termination step is going to take care of all the radicals in the system. I will just show a few of them. You have a BR radical plus BR radical. They're going to come together and they will make BR2. Then you also have this one we made right here in the initiation, RO. So I will make it here, RO plus H radical both. So I will bring them together and I will make ROH. And if you want to make this one, the radical of it, this one, we will see what it looks like. Probably something ugly or something. So I will make the radical right here. I will put the BR right here. This plus the same thing, BR radical right here. So we say that this one comes here and this one comes here, and you get what? You get, I'm going to draw this structure right here first. So I will make it there and the BR right here. Then I'm going to make the bond that I made with this and this radical. I will make it right here. I will put this methyl group going up, and then I will make the other one, and then I know that it has a methyl, and I know that on the second position it has a BR. And that's that.